Remember the binary search tree's nightmare? Sorted input, turning it into that long, slow whine? Well, balanced trees are the cure. The idea is this. After every insert, the tree quietly checks itself. And if one side has grown too tall, it performs a small, local rotation, lifting a child up, pushing a parent down, to even things back out. A red-black tree or an AVL tree does exactly this. The cost is a tiny bit of bookkeeping on each insert, and the reward is a rock-solid guarantee. The tree stays roughly log n tall, forever. No whines. Ever again. So you keep your O of log n search, insert, and delete, no matter how cruel the input order happens to be. And that guarantee is why balanced trees sit quietly inside language libraries everywhere. Databases then take the idea even further with the B tree. Instead of just two children, each node holds hundreds of keys and hundreds of children. Why? Because reading from a disk is painfully slow, and a fat, shallow tree means far fewer disk reads to find anything. So whenever you query an indexed column in a database, you are almost certainly walking a B tree. Balanced, shallow, and built for the very physics of storage.